Each element has a unique number of protons and thus a unique number of electrons. Electrons want to be as close as possible to the positively charged nucleus, so electrons will be in the lowest shell that they can be in. In other words, electrons will fill a shell before they occupy a higher shell. Table 3.1 illustrates the occupation of shells by electrons in some selected main group elements. For example, helium has a total of 2 electrons. We know this from the periodic table since the number of protons is equal to the number of electrons in atoms. These 2 electrons will occupy the first shell. Lithium has 3 electrons. 2 of its electrons will be in the first shell and the third electron will be in the second shell. Beryllium has 4 electrons, so 2 electrons will be in the first shell and 2 in the second shell. When we get to neon, which has 10 electrons, both the first and second shell are filled with electrons. Sodium, which has 11 electrons, has the first and second shells filled and then 1 electron in the third shell. The electrons that are in the highest shell are known as valence electrons. Valence electrons are really important to chemists since these are the electrons that engage in chemistry. We are mostly concerned with the valence electrons from main group elements and more specifically the valence electrons of nonmetals. The group number found on the periodic table lets you know how many valence electrons an atom in that group has. For example, hydrogen is in group 1A. Hydrogen has 1 valence electron. Carbon is in family 4A. It has 4 valence electrons. And chlorine is in family 7A. It has 7 valence electrons. The only exception to this is helium. Helium is in group 8A. It only has 2 electrons, so helium cannot have 8 valence electrons. The rest of the noble gases do have 8 valence electrons, however, which, as it turns out, is a very, very stable number of valence electrons. The periodic table is set up so that the period number or row number indicates the shell of the valence electrons of main group elements. For example, lithium is in the second period, so its valence electrons are in the second shell. Argon is in the third period, so its valence electrons are in the third shell. Cesium is in the 6th period, so its valence electron is in the 6th shell. On the other hand, the group number tells you how many valence electrons there are for each member of a main group, except of course for helium. Let's look at sample problem 3.1. Use the periodic table to determine the number of valence electrons in A, nitrogen, or capital N, and B, silicon, or capital S, lowercase I. Looking at the periodic table, we see that nitrogen is found in group 5A, so it has 5 valence electrons. Silicon is in family 4A, so it has 4 valence electrons.